Hello, everyone. Today, I would like to talk about how machine learning model can help patients with diabetes to manage their conditions with personalized recommendations. So let's explore several ways how machine learning can help. First one is glucose prediction, then insulin dosing, then monitoring and early warnings on some signs of serious conditions, then detect the diabetic retinopathy, which is the common complications in this case, and also provide some predictive analytics to forecast the likelihood of future complications. In order to better understand the business, I have applied CRISS-DM model. So the target user would be a patient with diabetes. The problem is the person needs to get early warnings in case of detected signs of hypoglycemia or hypoglycemia and take appropriate actions. Why it matters, monitoring and early warning is important for patients because it can help them avoid serious complications and life-threatening events. Currently, patients follow a traditional approach, which involves some self-monitoring of glucose level and regular visits of healthcare providers. To define the success, I would select the improved glucose control and reduce healthcare costs for the patients. So as for the metrics, I would measure the reduced number of hypoglycemia and hypoglycemia or some related complications, change in patients' glucose control over time so it will become more stable and reduce money on glucose control. For the model, it would be the accuracy. We would use mean absolute error and mean squared error. For the targets, there would be three metrics: reduced number of hospitalizations by X time, number of healthcare provider visits per month, and improved quality of life. The constraints would be regulations, model interpretability, privacy, and security. For the factors which would need to take into consideration, of course, it would be demographic information, patient's medical history, glucose and insulin data, medication data, what kind of medicine, doses, side effects the patients have, lifestyle data on the regime and activities, and of course environmental data like climate, humidity, temperature. The sources of data would be, of course, electronic medical history of the patient's, medicine data, glucose insulin data, lifestyle data, weather and climate data. For the features, as I have mentioned, would be, of course, the demographic data, medical history, biometric data, lifestyle data, behavioral data, genetic data, and environmental data. For the iterative approach, I would select four different stages. The first one would be a mock-up of the alerts and the recommendations to get the patient's feedback on data, on UI UX, and validate the business problem. Then we would take a subset of historical data and build a heuristic as a model to better understand what kind of data to collect and how to display, and then would be a simple model, so we would better explore the feature correlations and data insights, and then we would build a model and test it on a small group of patients to get their feedback on the model accuracy and ease of usage. As for the design choices, I would select the edge over the cloud because patients need a low latency solutions with real-time predictions and recommendations, and also there are some constraints with data privacy. I would select online learning instead of offline because we need a real-time adaptation to changing conditions in patient health. We cannot wait. And for batch versus online prediction, I would select online because we need immediate predictions generated as the new data becomes available. For the potential risks in production, I would select three groups. First one is model regulation compliance, because we would face a lot of regulations in healthcare system and domain, and we should follow. Then training servants queue, because the quality of the data used to train may not be that high in the real life, can be incomplete and inconsistent, which would affect the model performance, and of course latency. So the deployment and maintenance of the model can face the challenges like scalability, compatibility. In case of slow internet, may not give fast predictions. And I was thinking about the risk mitigation strategy. So for regulation compliance, we should make sure we have legal and regulatory assessments. We do all the best practices. For the data privacy protection, of course, encryption and secure data storage mechanism should be in place. For the data quality, we should regularly validate, clean, and update data. For the model performance, we need to implement performance metrics and regularly monitor how our model performs and test it. For the deployment and maintenance, that is a big challenge. So we should use cloud-based deployment solutions, containerization, orchestration techniques, which are best practices right now, and provide regular software updates and bug fixes. Thank you so much for evaluating this project with me.